came across an interesting podcast, the Big Brains podcast, which is the University of Chicago podcast, and they talk about big ideas. And one of the very interesting ideas that they shared was an institution at the University of Chicago called the Knowledge Lab, run by a gentleman called John Evans. He spoke about how to use AI to enhance science. I think it's an amazing coincidence. It's one of those things when certain apparently unrelated developments all of a sudden merge into one coherent thesis. So let me dissect that a little bit. So we have the Knowledge Lab, which thinks about how science is done, which looks at the sociology of science, the human aspects, social aspects, political aspects of science, with the goal to understand how these things work and to improve them. And the findings of the Knowledge Lab are that we have social impediments, that we have obstacles to overcome in terms of science, and that's why we have an exponential decline of the efficiency of science, where we invest a lot of money into academia and we get less and less results. Now, what is a result in science? Those things need to be discussed, but that's the finding. We have the application of AI for science, which also, now this is the other development, coincides with XAI being developed by Elon Musk, who specifically said in the Twitter Spaces when the founding of XAI was announced, that the goal of XAI is to enhance science, the understanding of the universe by humanity. So there's two developments which are very interesting, because the synthesis of those two is actually what John Evans says on the Big Brain podcast, which is that we could use AI and develop faster progress by making the AI less human. And this is the key insight, because humans are preconditioned to do science in a certain way, and that's part of the problem. And if we could develop an AI that thinks more like an alien, with the goal in mind to have more surprising results, then we could have better outcomes in science. This is the key insight, and I want to talk about this in this episode. This is not even on podcast. It's July 21st, 2023. This is Krim Delco. Since the last update, we're down 3%. The market is up 20 basis points. For the year, we're up 123%. The market is up 18.4%. We're outperforming by 104.6%. Again, I think the combination of different factors culminating in one conclusion, this is the beauty of this particular situation. So the situation is, again, we have AI, which is proliferating at a very fast pace. Foundation models being the really fundamental idea here, the fundamental novelty. And then we have, on the other hand, the Knowledge Institute at the University of Chicago coming up with research, which is incredibly important, I think, because what they say is, they say that with more money and more resources being put in academia, we have exponentially less results. And then we have AI, which could help fix that. And I think this is an unbelievable opportunity to actually do that. And the reason is because we can overcome almost all human barriers, which, according to the Knowledge Institute, are the main reason, by applying an AI which is not human. So instead of trying to replicate what humans do, instead of trying to be like humans or human-like, we should try to do the exact opposite. And this gentleman, Evans, from the Knowledge Institute, actually says something that we've been talking about in this podcast for a while, which is the history of AI. It starts with Alan Turing and starts with the imitation game, which is we try to imitate humans. And the imitation game, or the Turing test, is a test whether an AI can trick a human by being human-like. And this is a tradition that we've been carrying now for more than half a century, which is fine. It's brought us pretty far. We've developed some very good computer technology and infrastructure and AI. Now the goal according to Evans, according to the Knowledge Institute, and I think it should be according to Elon Musk's XAI, is to try to develop an AI which is not human-like in order to come up with more surprising results, because surprising results in science are the kinds of things which progress society. Now let me step back for a second and try to define a few things, because when we talk about things like science, efficacy, efficiency, I think we need to understand what we're actually talking about. So for example, what is it we're trying to maximize here? And I think what we're trying to maximize is what Karl Popper, what the ideas of the Enlightenment actually brought us, which is we're trying to improve the human condition. Okay, so we're trying to do less with more. We're trying to democratize access to resources. We're trying to increase the wealth of the world by increasing the possible transformations that humans are exposed to. This is a David Deutschian definition of wealth. We're trying to do that by coming up with new ideas, and those new ideas should help us develop new technologies, which eventually help us increase the amount of transformations we can do. I'm sorry if this sounds a little bit abstract, but let me put this in a more concrete context. As a human being, I have my muscle power and my brain power. If I develop a car, I can go from A to B. So the amount of transformations, the amount of things I can do increases because this car gives me more optionality. If I have a word processing machine, I can write texts much faster. If I have Twitter, I can exchange ideas. If I have airplanes, if I have rocket engines, so the more transformations, the more technology we develop as a human race, the better. Now, how do we do that? Well, we need science for that. The purpose of science is to come up with better ideas of how nature works. And then we can apply that knowledge through technology and engineering and make it actually useful for humans. So why do we need to understand how nature works? Well, it's our best guess of how to make technology. This is maybe it's questionable that we need to understand nature, because who cares? But in order to build a Golden Gate Bridge, we better understand how alloys interact with each other, how gravity works, how wind erosion works. There's just no better way to build technology, to increase the possible set of transformations, to make the human condition better, than to understand how nature works. So science is the endeavor. The purpose of science is to understand how nature works. This, by the way, is the mission statement of XAI, the company that Elon Musk brought into existence a few weeks ago, which is to enhance the understanding of human nature through the application of AI. And I want to close this loop. So we have the Knowledge Institute at the University of Chicago talking about a lack of progress in science. We have a statement of the goal separate from Elon Musk, which is we want to understand nature. We then have Elon Musk and XAI saying we want to use AI to better understand nature. And now I want to close the loop and say, yes, I agree. And the Knowledge Institute people like Evans and people like that, they say that the best way to actually enhance the effectiveness of science would be to dehumanize science, to make it less human, because a lot of human barriers, a lot of human heuristics, political, social heuristics, psychological heuristics, they play a role when it comes to hindering the progress of science. So if we can make science, if we can make an AI think less like a human and more like an alien, with the goal of enhancing the understanding of nature, then we could have more faster progress in science. This is the key insight. It's incredibly, incredibly powerful. This is something I definitely want to pass by Elon Musk. This is something I want to work on myself. This is something NVIDIA should be thinking about, which is in order to achieve better goals, particularly in situations where human barriers are the problem. And science is a perfect example. Actually, this goes even a little bit further. If we want to stop the progress of the academic industrial complex, which is hindering the progress of science, if we want to control that, the best way is to dehumanize science through the application of an AI which doesn't think like a human. This is the key insight. How this can be done, that's a whole different conversation. I think this is way beyond the scope of this podcast, or this particular episode, excuse me. But what we can say here is that the goal should not be to imitate humans. The goal should not be to build an AI which thinks like humans and acts like humans. In fact, it should be the opposite. And I have a sense, this is just a sense, this is nothing concrete or any of that stuff, but my sense is that if we build an AI based on reinforcement learning and self-play and things along those lines, then the AI will evolve organically into something that we wouldn't have expected. This is the key. Now, let me parse that a little bit. First, what are the human barriers? So Evans talks about this quite extensively. For example, we have an incentive structure in modern academia which maximizes for citations. And the result is that people cluster around knowledge, and they don't have the incentive nor the courage to deviate from that knowledge. And as a result, we have more incremental knowledge being developed, which is fine, but it's not really. But the progress in science is when the sort of Kuhn-esque paradigm shifts happen. That's when we really move forward. And they happen, but they happen, of course, relatively randomly, and they happen, they're difficult to predict. And if we look at David Deutsch, for example, who says that it's all about creativity in the end, well, creativity is something we don't quite understand yet, right? We don't understand creativity. So it's relatively difficult to build an AI that is creative and that comes up with surprising results. Surprising results are defined as results that would not come out of a cluster of knowledge, of a cluster of established scientists. And what I mean with that is Evans, in his Knowledge Institute, actually has done something pretty interesting, which they have built a model that predicts discoveries. And it's quite shocking that they're able to do that, because it shows you how, if science is this predictable, it cannot be interesting, it cannot be surprising, right? It cannot be paradigm shift type science. This is incremental. If you can predict what Tesla's going to do in the next 6 months, if you can predict that, that's not a good sign. You want the element of surprise. You want the element also of failure. You want try and error. You want to maximize try. This goes back to the foundation also of Orange Capital Partners, which is to invest in fundamentally new concepts and engineering practices with large impact. And the process that we're looking for is iteration through enabling a rapid amount of iteration with a relatively low cost of failure and a low cost of error correction. This is what you want. This is what you want to maximize for. So you want failure, but the failure, of course, has to be low cost, and the error correction should be low cost, etc. Now, again, this is a little bit beyond the scope of this episode, because now I'm really going almost, into the core of what Orange Capital Partners is about, what disruption is about, what the theory of disruption is about, what wealth creation is about, what preparedness is about, what, even the whole story, even the whole conversation of things like the Enlightenment and the fundamental idea of the Enlightenment. So we're really crossing many, many bridges now. And of course, too many. We don't want to do that in this particular episode, because otherwise it's going to become relatively difficult to keep the oversight. So what we want to focus on here simply is we want to say that, look, there is a problem, which is lack of progress in science. The problem is being hindered, science is being hindered, or the problem is that we don't have, that we have too many human barriers. We have too much institutional inertia. And how do we overcome that institutional inertia? Well, one thing is, of course, we can change the institutions, which we should be working towards also. I'm not saying we should completely neglect that. We can build better academic institutions with better incentives. We can de-incentivize clustering and incremental knowledge creation, and we can improve the chances of surprise discoveries by increasing the rate of iteration, by lowering the cost of failure. So we can do all these things in an institutional framework, the same way we invented, let's say, the same way we invented the democracy, and we came up with better ideas for democracy, etc. In this exact same way, we can also improve academics. However, we have this new space, which is the digital space, the space of AI, which is opening doors for us that weren't open before. We can build an AI that is maybe through self-play. Now, how that can be done, again, I don't want to go into details about that right now. But what we can do is we can build an AI that comes up with a process of scientific discovery which is not human. So it's not the imitation game that we're trying to build here. It's the exact opposite. We don't want to do it like humans. We want this AI to come up with new ways of doing science. It's not hindered by things like maximizing for citations. It's not hindered by ego and, for example, impressing other scientists with jargon. It's not hindered by things like family structures, like your father was a professor and you better also get tenure, and you better get tenure at a prestigious institution instead of going somewhere maybe where people are more risk-taking, but they're not as prestigious. So you want to get rid of all those biases and just focus on iteration with a low cost of error and low cost of error correction, and keep iterating. The AI also has the luxury to come up with lots and lots of ideas that potentially are not going to work. Maybe we can also develop a sort of an animation game here where we can play out those ideas and see how far they can get us. So we can maybe play around with execution also. I think this is a very interesting idea. Like I said, I keep saying the same thing. I apologize. Like, I don't want to now bring the solution and how it's going to be done. I just want to focus on the idea. Dehumanize science through applying AI, which is dehumanized. And I mean that in a positive way. Not that I want to build an AI, sort of a robot AI that kills humans or something like that. What I'm trying to say is that I want an AI which is not hindered by all the human biases that hinder us right now in science. This is the conclusion of this episode. This is what I've learned through listening to the Knowledge Institute podcast on Big Brains. And I want to finish this episode now with also just a shout out to XAI and Elon Musk. This is a unique opportunity for this company to actually develop that kind of AI. And this is something I'm going to actively participate in conversations, Q&A, well, whatever access I can get to this company, I will, hopefully be able to introduce myself into the conversation by trying to, again, to steer the evolution of an AI for science that is free of human barriers, social barriers, psychological barriers. This is the key. So to summarize, the Knowledge Institute at the University of Chicago has come up with some interesting research, basically confirming what we've already been thinking here at the Orange Capital Partners, which is that we have a declining efficiency of science. More money goes in, less comes out. The reason for that is clustering, institutional biases, human biases, psychological biases, political biases, all those kinds of things. So we have less surprising results. We have less iteration. We have an aversion to failure. This can be overcome by applying AI to science. And the big power of AI is that it doesn't have to be constrained by all those human constraints that we just mentioned. It can free itself a little bit like AlphaGo Zero when it started making moves that humans would have never done. This is what we're trying to achieve with an AI that does science. Thank you.